Hi, welcome to your presentation today. This is going to be the lab safety portion or introduction to your new credit as far as we go. We're going to talk about lab safety and your rights as an individual in those measures. So, as an employee within a work environment, you're allowed to contribute to the health and safety of the work environment, and you're also allowed to refuse work if you think it is going to be dangerous to your health. To do that, you need to understand exactly the health and safety implications within the work environment around you.
Now, this is kind of cool because we talk about health and safety in terms of preventing injury. We also talk in health and safety how we mitigate and prevent being the same thing, as well as how we treat injury, how we look at things in that sense. And legally, you are able to participate in this, and also legally, we are actually part of it, have a role in educating you on this one. There's basically four steps in this, and this is in every workplace. And we're going to actually talk a little bit about COVID on this one as well, because it has a role to play in this. We basically have to identify where the hazards are in our workplace, and we're also going to talk potentially with your assignment around your home. So what is actually causing the problem in this case? We then have to evaluate how bad is it, because some risks are negligible. They don't actually matter. We can somewhat ignore them, or we can educate against them, for example. But some risks are actually very hazardous, and we have to build in engineered controls for them. We then manage them. We figure out how we're going to prevent it. And again, those are some of those methods that we could use. And then we ask ourselves, is the situation changing? Do we still have the same situation we had when we did the safety assessment, or are things changing? And I just want to point out that in the case of our current situation with COVID-19, this is actually what's happened, right? We've identified that there is potentially in this case, biological hazard floating around the world. We've evaluated the risk of the fact that it could infect many people and cause a very large strain on our society, and we've actually decided to manage it through things like physical distancing, and in this case, getting you all out of schools and onto your computers so that we don't pass the spread of this disease on in a very big way. We'll continue to be diligent about that because obviously it's an ever-changing situation. Now, the hazards come in 5 main flavors. This is pretty standard across all health and safety theory, and we use this to classify our different kinds of hazards because how we deal with each of them is drastically different. We have physical hazards, chemical hazards, electrical hazards, ergonomic hazards, and biological hazards. So let's break these guys down. First kind of hazard is a physical hazard. These are the ones you're probably most familiar with. Tripping, falling, bandsaw blade, power tools, hand tools, anything that could physically damage your skin and or person. Something like driving a motor vehicle poses a major physical hazard in the case of an accident. These are all kind of categorized as, like I say, slips, trips, and falls, and or hitting or cutting things. And in our lab specifically, we do have some of these. We have machinery like 3D printers, CNC mills, and even moving robots that actually pose a physical hazard.
Second is chemical hazards. One of the best ways to identify a chemical hazard is through its WHMIS symbol, which I will cover in a bit. Examples in our lab could be mercury light bulbs. So, for example, some fluorescent light bulbs have mercury in them. When they're broken, it produces a chemical hazard, i.e. the mercury that goes into the air that could physically harm you. You can think of other chemical hazards along the line of toxic. So say you're doing a home safety overview and you come across bleach, HCl. That is a potential chemical hazard that could cause irritation to your skin or could be poisonous. So chemical hazards are things in the environment that are chemical in nature that can cause damage to your person or others around you.
The mercury light bulb actually comes with a story. When I was cleaning out one of my old robotics labs at another school, I actually went through the storage room, and on the one shelf there was a somewhat broken up cardboard box with foam inside that actually had a giant strip of tape over top of it that said mercury light bulb, do not touch. Now, when we talk about mitigation methods and how to actually deal with that, that's the wrong way to deal with it. Don't simply label it as dangerous in some cases. We did actually end up disposing of that one properly.
So WHMIS, or the Workplace Hazardous Materials Information System, is a standardized system that allows you to identify and classify different compounds and the hazards that they could cause. Usually all WHMIS stickers are put onto the container or in the area where a chemical hazard is contained, and that alerts you also is accompanied by a sheet that will be in a lab safety binder or a binder that is on site that allows you to identify and the risks that are involved, how to handle a material, how to, if exposed to a material, mitigate the exposure or take actions to help yourself within that.
In our lab, the safety data sheet binder lives on top of the phone right near the door in room 1232 in the lab side. Now, electrical hazards are interesting because we do deal with robots here. And it's funny to look at because when we look at how hazardous they are, we really have to look at what level of electricity we're dealing with. If you're dealing with under 5 volts, you're pretty much not going to harm yourself. It's actually very difficult to do. In fact, if you wire up a pumpkin just right with the right metals, you can actually produce 5 volts pretty regularly. But the fact of the matter is, the higher the voltage, the more danger there is. And we have to be constantly on guard for this because we do have some of our electrical cords in the lab that do have 120 volts alternating current running through them. That is something that could be potentially hazardous to you. So we have to constantly monitor the situation and make sure that those wires are in one piece, that we haven't, say, dropped a soldering iron through them so that they actually connect and cause an electrical short, which is a true story. And basically, we talk about electrical safety in terms of getting rid of the electricity. That's kind of our first go-to with anything electrical safety, including electrical fires, which we'll get to in a second. Basically, if there is an electrical problem, we want to make sure that there is a fuse, a breaker, or a way for us to turn off the power in order to prevent that electricity from flowing, because once electricity is moving, it's actually somewhat hard to stop. And electrical fires are one such example. It's one of those pieces when we talk about how to prevent a fire, how to put out a fire, we often say things like, well, put water on it. If you put water on an electrical fire, you actually have a much more significant hazard than you would have if you didn't do that. And so go straight for the source, turn off the electricity in any case of an electrical fire, and then deal with the fire. The next kind of hazard, these are a bit of a weird one, and they're one that you probably or maybe haven't talked about before. Ergonomic translates in Greek into work system, that nomics piece on a lot of systems, and improper position causing tired or strained muscles is actually a really big problem in a workplace. You as students probably never actually deal with this because you constantly move, and you probably sit there and go, oh no, my physics class, we don't move. We sit there and we actually go through stuff and I don't move. But you actually are moving every hour to hour and a half in school constantly. What we're talking about with ergonomic hazards are people like people in manufacturing, where they're constantly doing the same motion over and over and over again. You often have things like you actually have things like somebody who gets carpal tunnel syndrome, where their wrists actually start to get inflamed or swollen because they're constantly typing on a keyboard in a really weird spot. Tall table computers with low chairs. We have different methods of dealing with ergonomics, and I do actually implore you to go check this WordPress document. It talks about different bad posture that might go into how you're actually working. This has actually led to a lot of people will sit on exercise balls, for example, to keep parts of their body moving when working at a computer, or they'll use what's called a standing desk. And you'll see a few of those around the school more and more, where secretaries, I know our principal actually uses one now, where they actually stand at their desk and are working on a computer there so that you're not constantly sitting for long periods of time. It's actually a major piece of our healthcare system dealing with things like carpal tunnel and lower back pain, where people like, let's say, a truck driver or bus driver are constantly sitting for hours and hours on ends. Their work system is actually causing them harm and requiring some sort of treatment. We prevent this by actually engineering the environment to be more ergonomically sound, better for the human condition.
Biological hazards are our next hazard, and this one covers any substance that could carry a bacteria or virus. So when you're thinking about this, you're thinking about saliva, sweat, blood, blood from cuts. Blood from cuts is going to be the number one biological hazard that we will probably see within the lab, because the blood coming out of cuts can be a high concentration of bacterial viruses that a person could be carrying. If you think today, why are we social distancing? Well, our breath can actually carry potentially a COVID virus within it, and we social distance 2 meters apart because we believe that biological hazard can be mitigated through that physical distancing from each other. In the lab, what you need to know is if you are cut or a person is cut, we need to take care of that blood that is coming from that wound. If it is a small cut, you would go get a band-aid, or you would go to the bathroom and put pressure on with a paper towel. Um, if it is a larger cut, you need to make us aware in the lab right away so that we can get you the medical attention that is needed, whether it is comes in larger forms of gauze or XYZ, all the way up to calling 911 and you being taken to the hospital if it's a serious enough cut from a larger device that could potentially cause catastrophic harm to you. Further from that, we then need to also sanitize the area that any of your blood or anyone else's blood could touch before anyone else is allowed to use that area. So if blood is spilled, say, on the countertop, it is also very, very important that you make us aware so we can take the appropriate measures to disinfect and sanitize the area so that it becomes safe again for anyone else who may want to work at that area.
And we'll talk a little bit about documenting and reporting things here, but Mr. Johnson brought up a good point there that anytime you have some sort of injury that happens in the lab or in any workplace for that matter, it is a good idea to report it, even if it was something that was relatively minor. The thing that follows is that we then investigate and we do that diligence piece, which is our last part here, to actually follow up to make sure that the environment hasn't become unsafe in some way or another. And that's a huge piece of what we do here. Okay, vocabulary's done. We've got something we can talk about in terms of different kinds of hazards. So let's talk about how bad these things can be and how we fix them as well. We're going to talk both about kind of figuring out the level of risk as well as talking about mitigation here. So a 5-volt proto board, which is our breadboards that we'll be dealing with the next couple of weeks, are really low risk of injury. Again, you can put your fingers against a 9-volt battery and probably not really notice that you're actually touching a 9-volt battery. But the 120-volt wall outlet is a rather high risk. You will know that you have had an electrical circuit going through it, both due to the potential pain if you make contact with it, and anybody who's touched 120 volts AC before knows what I'm talking about. As well, you will find a significantly sized explosion from that sort of thing. Now, the funny part is we need to manage these things. So if we talk about the 5-volt proto board, we're probably not going to manage that risk at all because there's a very, very low chance of harm. But if we're talking about something like, say, a soldering iron, which is going to heat up to 700 or 800 degrees on the tip, we're probably going to build some sort of education program. We do when we do soldering. And for all of you who are wondering about your soldering piece, if you don't do it in grade 10, we will move that to grade 11 for you. We'll talk about it. And with the end of that soldering iron, we're going to teach you how to lay out your actual workstation so that your hands never have to cross, for example. So you don't have stuff in the way that could potentially tip the soldering iron, make you drop the soldering iron, and make you make contact with that really hot end. It's a funny aside, when we talk about soldering, we often use, actually there's a sign at one place I was working at with soldering irons that said, if it smells like chicken, you're holding the wrong end. We educate for these things. We actually make it so that you've got the ability to not injure yourself on them. So for 120 volt wall power, we just make sure that we always have some sort of insulator or protective equipment between us and the wall, or us and the power. In many cases, that's the plastic covering on the wire, and you probably have a few of those in your house right now, probably within sight. Okay, if you went into the actual electrical part of that wire and touched the wires together, it would be a hazard. Now in your home, that rarely ever happens, but I've seen this happen where pieces of metal were dropped on a power cord and actually caused the insulation to become damaged. In this case, we actually just have to mitigate this by inspecting our equipment frequently. We do this with the soldering irons. We inspect the cords before you plug it in every single time. The reason for that is if somebody's accidentally melted through the insulation, and very rarely have I ever seen someone do that on purpose, they get the soldering iron too close to the power cord, the insulation melts, we can see exposed wires. That's not good. In this case, our mitigation method to prevent this is inspection. We inspect the equipment to make sure everything is still in place. In some extended circumstances, like higher voltage things, we actually have to build in a fuse or a breaker. A breaker in this case, if you were to, say, melt the insulation on your power cord and connect the two halves of the electricity, or two halves of the circuit, to actually make the electricity flow, a breaker back in the breaker room, and this is in the lab, but it also works at your home, would actually trip, and it would kill the power. It would stop the electrical current from traveling through that wire. The mitigation in that case is an engineered way of solving the particular problem. And basically what you guys need to know in our lab, the highest voltage you will ever deal with is 12 volts direct current. That's directly. You may end up in contact with 120 volts AC if you go through a power cord, but I recommend that you don't. The 12 volts DC is often used to power, for example, our large-scale robots, and it is enough to actually cause you a fair bit of a fright, though long-term damage is probably not very likely. In that sense, we put insulation on those things, we put breakers on those things, and we put safety programs into place where we just make sure that nobody is in contact with those electrical circuits before we turn on the main power. We often make the breakers on robots actually quite visible so that we can actually access them very easily in the case of somebody getting too close or something not working quite right. The other piece we might do, and you probably all know what this term means now that we're in the COVID era, is personal protective equipment. Now, our PPE for COVID looks like face masks, sometimes for people working in high-risk areas, looks like goggles or safety glasses, gloves potentially, and protective clothing. In our lab, when we talk about electricity, the personal protective equipment we are most likely using is safety glasses. In all robotics competition, we actually require them in the pits, just in case something moves that's not supposed to. You only get 2 shots with your eyes, and it's not really a good thing if you end up damaging or losing one of them because they are very fragile. Potentially, we may also have to use gloves with some applications of certain substances, just so we don't get them on your hands. But that's the majority of what we use in our lab. Another example of PPE we see in the school as well is in aviation. They have ear defenders, as they call them, which are hearing protection. If you're constantly working in a high noise environment, that is actually a hazard to you, and it's something that we would like to mitigate and protect in those cases. So the last stage of all this is basically to make sure that people are being safe. If you see somebody doing something unsafe, that's everybody's problem. Please let them know about it. In my experience, working in industry, working in the lab, nobody is trying to walk away from work injured or ill. It's not how we work. Usually what happens is somebody's trying to cut a corner or is ignorant of what's going on. They've done something unsafe and they don't know about it. So please, 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 I implore you, tell them what they're doing is unsafe. 9 times out of 10, they look at you and go, oh yeah, that is unsafe, and they fix the problem. They didn't notice. And you looking at it with fresh eyes is often the thing that is the determinant between them working safely, working unsafely, being at work tomorrow, not being at work tomorrow, etc. So if you see somebody not working safely, please let them know about it. They will try to fix it. In our lab context, because it is educational, if they continue to do the unsafe thing, please come tell your teacher. And lastly, just to kind of keep our diligence piece going, if you have a near miss, that's something you should report. A near miss is something where, the power cord was melted through and you repaired it. Please let your teacher know. We like to record these things because it tells us that you're understanding the health and safety piece. It also helps prevent future incidents. An example I use in class, and we often do this as a discussion, but we won't have the ability to here, is this would be an example of an actual incident. This is not a near miss. This is actually something that happened. Now in this case, this worker gets flung off the edge of this truck because he was unaware of his surroundings. In this case, this is a physical hazard in the worst possible way, and probably quite a high one because he could have sustained serious injury here. Now how do we prevent this? This is something where perhaps this is a worker that needs some sort of visual marker on his lift gate on the back of his truck to prevent this from happening. As well, it's also possible that it's a case where he might want to start backing the pallets off of the truck in this case to better prepare or better be able to deal with this, or even move them sideways. I've seen some drivers do in this case. This is something where we probably need to have some sort of hazard control in place because there is the potential for bodily harm in this case.
So emergency measures are the measures we take in case of emergencies that could arise in the lab. The 2 most familiar that you are within the school context, and especially for our lab, is in case of a fire drill or a lockdown. In case of a fire drill, we should all exit in an orderly fashion to the nearest exit, line up alphabetically to make accounting for everyone easy, and if you're in the washroom, find the closest door and then find our class. In addition, I'm going to add that in fire drills, it also pays to be quiet as you can, just because then if there are additional instructions, like can you move further away from the building, that you follow those and can hear them in the case of an order that is given to you. In case of a
I want to add on for my classes, when we meet for a fire drill, you'll find me pretty routinely about 200 feet away. I'll be closer to the Royal Bank outside the front doors of the school than I will be to the school itself. Reason for this is rather simple. I was actually part of a fire drill where we were out of the building for most of an afternoon because there was a gas leak in the building. You never know. That might be something that happens. It wasn't at Mandela, it was at a different school. But if there's a gas leak and something does go wrong, you don't want to be standing near any type of glass, anything like that. Go hang out in the field. Get away from the actual building itself. It makes it much easier to communicate with you. It makes it much easier to manage the situation, and it makes you much safer long term.
Also, in case of lockdown, we turn off any machinery and sit down on the floor and maintain silence. You can think of this as, if there is a reason for the lockdown and someone is actively going through the building, we don't want to alert them that we're in the room. Turning off the machinery takes that noise out of the room, allows us to be quiet, allows us to act as though there may not be anyone in the room, and it may be worthless to actually enter the room. There are emergency cutoff buttons within each room. These measures are taken in case of the need to stop electricity or current throughout the room. Please note that these buttons are for extreme emergencies only, and hitting them with no good reason could result in you being removed from the lab for the remainder of the class, potentially the semester. The reason this is you can think of our computer room where we do have a red button. If you come through and you hit that button, think of all the work that the other students may have been doing during that class that could just be erased from the computer. You're causing distress to them because they would have to go back and do it. It is potentially, you could be taking a whole project away from a student, which is why we only use these in extreme emergencies. So think about, I see someone who is potentially going to stick their hand in a bandsaw. That would be an extreme emergency where if I'm standing beside that button, I would hit it and then go have a conversation with that student. Or if an electrical arc is being created by, say, wire that has now become loose and is throwing sparks, I'm going to hit it so that the electricity will no longer go through that wire. Those are good examples of an extreme emergency that would require us hitting those red buttons that are located near the door. To note, if you do hit those buttons, your teacher has a key to restart them if we deem the area is safe. So if there is an emergency, an extreme emergency, the button is pressed, we then go tell our teacher. Our teacher will do a walk through the room, make sure that it has become safe again before we turn it on.
And you're going to see these in industry in places where there are large pieces of power machinery, just so that it can be cut. In our lab, in our case, it's actually because we are working with electricity. And I have seen that situation that Mr. Johnson just described, where a soldering iron goes through a power cord and does actually start throwing off a significant number of sparks. I've had to use this before. And in 5 years of, I guess it's now 6 years of doing this, I've really only needed to use that red button properly twice. And if you're in that case where it's happening, it is absolutely invaluable because you may not be able to get at the actual power cord or the piece that's attaching to the wall, but you still need to cut that power. All right. Again, we don't take using those red buttons lightly, but if you do need them, you absolutely need them. They are the best solution. I just want to put a note in here. If you see a fire in class, and one of your assignments for this week is about lab fire safety, as well as workshop fire safety in general. Don't use water on fires in the class. We do have a fire extinguisher in the workshop side of the lab. It lives on the tool shelf at the back of the room. It will work on anything that will possibly happen in our room, but most everything we've ever had, including that situation where I had to use the actual red button, actually just required cutting of the power, and then the fire did go out. That's probably more than likely what's going to happen here.
So it's hard for you guys to ask questions to this presentation, but we encourage you to ask questions through email or even to log on during this week to our online sessions. For example, tomorrow morning at 9 a.m. if you have questions, or in the afternoon with Mr. Way.
At 2:30 tomorrow.
at 2:30 tomorrow. Please log on to those so that you can ask us any questions that have arisen through this. In addition, I would also like to encourage you, if you found this interesting or want to actually take it further and gain more knowledge within this area, to email me or Mr. Way about the course HCS 3000. Some of you may have already taken HCS 3000, some of you haven't. What HCS 3000 is a workplace safety 1 credit module at the 30 level that you can actually take and complete. If you wish to do that, take it, complete it, and learn more about this subject, you'll be granted with that 1 credit at the 30 level. We will make sure that you get it. If you're interested in taking that course, please, again, email us, Mr. Johnston or Mr. Way, or attend one of our online sessions, and we can get you set up with taking that course and get you the credit for it if you complete it.
Cheers, guys. Stay safe.